So in the next couple of days, we're going to be applying all of the new skills that we've learned in the first few lessons to solving some analytic geometry questions. So there are several significant terms, new terms, that you're going to need to know in order to manage solving or proving whatever is being asked of you in the next couple of days. So I'm going to forewarn you that it is challenging and it's going to demand that you use a few different tools together to solve a single problem. But we'll try to take this slow. I'll try to, explain to the best of my ability how it is to break questions down piece by piece in order to answer the question at hand. So before we do that, let's take a look at some really important definitions, terms that we're going to see throughout the next couple of lessons. So the first one is one that we've seen already, but I'd like to reiterate it just to see if you can recall what it means. So the median is the line connecting the vertex of a triangle. And so the term vertex just means corner. So a triangle has 3 vertices, 1, 2, and 3. And so if we're talking about the line that connects the vertex of a triangle to the midpoint of an opposite side, so let's just say, for instance, that I were considering this vertex right here. Then I would be looking at the line that would be connecting that vertex to the opposite side's midpoint. So the opposite side is this guy right over here. And so I'm going to kind of guesstimate for the purposes of illustration where the midpoint might be. So if I guesstimate that the midpoint of the line of this side is about there, then I'm saying that this length and this length are equal to each other. So where would the median be? Well, the median would be the line that connects this vertex to that midpoint. Now, you of course would have a ruler and that line would be straight, but that is what a midpoint or a median is. Okay, so this line right here, that is my median. So here's my next term. The next term is a right bisector. Now I should let you know, because it just occurred to me, that sometimes this is also called the perpendicular bisector. Okay, so just like right angle means perpendicular to the base, there's a 90-degree angle in there. A right bisector or a perpendicular bisector is a line that is perpendicular to the line segment and divides the line segment into 2 equal parts. So we're going to be seeing this a lot in triangles, which is why I decided to use a triangle. So I'm going to imagine that I am going to find the right bisector of this triangle. So I'm going to label this triangle first, just because I think it'll make it easier to reference different aspects of it. So let's say I want to find the right bisector of BC. That would be this side right here. So I'm going to start with that side. Then in order to do that, the right bisector is going to divide this line segment into 2 equal parts. So in order to divide BC into 2 equal parts, I'm going to find the midpoint, right? So, I'm going to call that little point M, okay, because it's the midpoint. So if I'm going to draw the right bisector or the perpendicular bisector, then what I need to do is I need to take that midpoint and I need to find a line that is perpendicular to BC. So in other words, at a right angle to BC. So I'm going to create my line kind of like this, and it's going to go to wherever it goes across the way. So here I've created this perpendicular bisector. Let me just do a little bit better of a job here of it. So I'm going to like that maybe. Now if that were straight, then I would have a right angle here. And so it's not so important that this line meet the vertex. As you can see, right, the line is not ending up on the opposite corner like with a median. But it is important that it divide this line BC in half. So here is half, here's half, right? So, and that is the right bisector. So some important ideas about this would be that if I knew the slope of the line BC, okay, then I could get the slope of my perpendicular or right bisector by taking the negative reciprocal of the slope value for BC, okay, because they are perpendicular to each other. So that's something that you can sort of expect to see. Yeah, okay, moving on. So I thought maybe it might be useful to also show you what the right bisector would look like if I were looking at a different side. So let's say, for instance, I were looking at the side AC instead. Then I would go ahead and I would find the midpoint of that. So I'm gonna guesstimate, but you would use some math and the midpoint formula to do so. Here is about the midpoint. And so I would be using my protractor, or I would just be, if I were drawing it in, I would use a protractor. And so I would be looking to draw a line perpendicular to that other one. And it says, if I were guesstimating and assuming that this were a right angle, then this side, or this little segment here from, I'll call this M, from A to M, would be equal to M to C in terms of length. But here would be my perpendicular bisector that's sort of hitting right over here. So just for comprehension, what I want you to do is, imagine what the right bisector of side AB would look like. So what would that look like if I were finding the right bisector or the perpendicular bisector of AB? And when you're ready, then I'm going to go ahead and show you. I'm doing that right now. So if I were to kind of say that here is the midpoint, I'm going to call that M of side AB. Then the perpendicular bisector would be a line that would be at the right angle here, like this. And then it would kind of keep going and meet wherever it meets on the opposite side there. That would be my right bisector. Hope you did okay with that. Yeah, I'm going to try to go through a couple other terms. Alright, so what I'm going to do is I'm going to switch to our next diagram. Oopsies, I guess that's not going to erase. I'm going to erase this for us. Here we go. Boom. And move to our next definition. Alright, so the next definition is altitude. So altitude describes the distance, the perpendicular distance from a vertex to the opposite side. So let me go ahead and label this triangle. I'm going to label it as A, B, C. And when I'm talking about the altitude, well, people think of altitude in terms of like above or below sea level. Maybe you're thinking about the altitude of a mountain. To me, it really describes height. And so it's the same in this situation. If I'm talking about the altitude, I'm talking about basically the height of the triangle. So if I were to describe the height relative to vertex B, then what I would want to do is I would want to create a line right down, and I'm just going to kind of eyeball this, to the opposite side and create a right angle. Okay, so that would be what I would call the altitude of this triangle, the altitude relative to vertex B. Now I could also, even though it's not necessarily describing the height exactly, or it's harder to think about it, I guess, I could also describe the altitude relative to the two other vertices. So for example, if I'm finding the altitude relative to vertex A, then I would simply be drawing the perpendicular line to the opposite side. So let me try to eyeball that. It's a little bit tricky because it's on an angle. Normally I would want to switch my page around, but I can't exactly do it. So, if that's the height relative to A and I've got a perpendicular line to the line BC, then what I've created is an altitude. And of course I could do the same process from vertex C all the way to side AB. So that is altitude. So the last term that I want you to know is a chord. So a chord is essentially if you were to draw a circle, or if you even have a curve, it doesn't necessarily have to be a circle, but if you have a curved line and you join parts, you find any 2 points along that curve, and then you join those 2 points in a direct or straight line, then what you've created is a chord. So this thing right here, this line AB, that is our chord. So of course, if you know the equation of a circle, then you can determine if points A and points B lie on that circle. And then once you have that, you could also figure out what the equation of that line is from A to B. So those are some of the tasks that we may be doing in the next while. So what I'm going to set up for you is I'm going to set up quizzes, and I'm going to post it on Google Classroom for you to try. And it's just going to ask you which of, to help you maybe figure out what term is what, and it'll just ask you some questions that'll demand that you try to make sense of the differences between a median, a perpendicular or right bisector, the altitude, and a chord. And you'll need to understand these terms really well because tomorrow and the day after, we're going to have a couple of lessons where knowing these terms is going to be really important. But that's the end of today's lesson. Spend the time investing in making sense of these definitions and you'll be off to a great start.